I want to talk briefly about local variables, function calls, and how they relate to an important region of memory known as the stack. If we look at this piece of code that's running now, I've set a breakpoint and stopped the processor. I'm about to initialize two local variables, A and B, to values 1 and hex 20. Now there are two special function registers, low in memory, which keep track of the frame pointer, which is wreg14, and the stack pointer, wreg15. So we look at the frame pointer, that's 8D0. Here's memory over here. 8D0. Okay, that's currently got nothing there. It's all zeros up here. And 8D6, which is the top of the stack, which is there. Now, let's watch the memory, watch the stack region of memory as we step through this code. So we set A to 1 and B to hex 20. And indeed we see these variables appearing on the stack. And they're on the stack because they're local variables. They're within a function. And their scope is only within that function. In other words, outside that function they don't exist. Unless they're global variables which are declared outside a function, such as this one up here, x. Okay, so we've landed on a line now where we have a function call. And that function call is going to pass A and B as parameters. Now, let's have a look at the function. Here it is. It takes two arguments, both integers. It sums them together and returns the result as another integer. Dipping into the disassembly listing, here's the function call we're going to make. That's the C instruction, and these four instructions here are the corresponding assembly language. And the clue is this call, rcall. That's the actual function call. The address to return to when that function is finished is the next instruction. It is 2C6. Now if you write that down on a piece of paper now, hex 2C6. That's going to be our return address. So if we step into the function, let's have a look at the stack, and indeed we see 2C6 as the first thing that was put on the stack. You also note that P and Q, hex 1 and hex 20. 20 and 1. They've been copied onto the stack as well. So arguments to a function are copied onto the stack, and the return address has been copied onto the stack. We've also got this local variable y, and we'll see that change. That'll be on the stack as well, of course. So y equals hex 21, and sure enough it's appeared there on the stack. And then when we return, before I do that, let's have a look at the frame pointer, 8DC. 8DC. So that's the beginning of the memory for this function, for its stack region. So there we are, 21 and 20. Yeah. Stepping over this and back. We're back into the main code, and the frame pointer has been adjusted back to 8D0, and the stack is back to 8D6.